about the lessons we had from 3 robotic startups. And the motivation is robotics researchers come at a point where they think that the technology may be of use in the real world for a real customer, a real product. And often researchers use this as motivation. And I would like to explain how this way could be to such a product and what are the pitfalls and what are the, I would say, the lessons which we learned you should consider. So why? We have so many brilliant robotic ideas, but only few survive and make it to the market. So in this talk, I will mention 3 examples of spin-outs from our lab. The first is a collaborative safe robot arm. The second is an autonomous stair-climbing wheelchair or load-carrying robot. And the third one is inspection robotics. I will look at 5 dimensions of the startups. This is my selection. First, I will look at the technological innovation, then at the market hypothesis, the team, the funding, and a summary of the outcome and the development of each startup. Now, the first one is bionic robotics, and we address a safe, ultra-lightweight collaborative robot arm. The technological innovation. Now look at robotics. Since 65 years, since the first patent of an industrial robot arm, robots are mainly designed by the principle of rigid kinematic chains of rigid joints and links. Mechanical elasticity is considered harmful, usually, and the typical control concept, typically we have electromechanical rotary joint actuators, and the control concept is usually all motions are fully feedback controlled at any millisecond. We have a low latency in the controller, and we have usually a cascade of single input, single output controllers in joint space. Now, if you look at humans and animals, they are designed differently. They have bundles of highly elastic linear actuators, the muscles, and they can only contract. So we need bundles of them, antagonistic pairs to move a joint. We have feedback control only for slow motions because our neural signal system is much lower than in our robots. So we can only do this for slow motions, and fast motions must be feed-forward controlled. And we have high latency, and we have a multi-input, multi-output control in task space. It's quite different. So how can we come to the performance of humans in this direction? Of course, we need elastic actuation. And in this case, we are investigating tendon-driven actuation. Like the human arm, it has 2 antagonistic pairs of muscles which actuate the elbow joint in this case. Now, to copy that or go for this principle, we use antagonistic pair of elastic tendons and an electric motor which can move backward and forward. By this, with one motor, we can move this elbow joint forward and backward. And this is a design which we have developed, one of these designs showing this. I would like to show a video which we prepared in 2015 for fairs. So to showcase the highlights of this development. At this time, in 2016, the new specification for collaborative robots came out. And we showed that our solution extremely well matches the safety for the critical case of clamping, of physical interaction with humans. So by using these tendons, we can actually move all motors to the base. And the remaining parts of the robot, all motors are in the base. The remaining part of the robot is then very lightweight and compliant. And it backs up immediately when it collides unexpectedly. And the most critical part, which is clamping of an object, of a human part, can be done even at a relatively high speed. It is very different to conventional robots. Conventional robots need force torque sensing and estimates for estimate unknown collisions, unexpected collision, and then back up. And this takes quite a number of milliseconds. Now, these are experiments we did with force plates. We measured the maximum use with the maximum speed of the robot arm. We had these collision measurements, and we measured the impact. And you see how this easy soft compliance and back drivability makes it really below all this, the limits here. We'll show this in a figure soon. So this robot is uniquely most close to humans in terms of the design and in terms of the usability. Its safety is independent of the software, and it's very easy. So it's very lightweight. You see, it's easy to carry. It's easy to put it on a desk and easy to teach in because of the software. This is from the specification here. This is from this ISO technical specification, and we have speed limits. So the robot effective mass and the speed limit, these define the criteria for safety in close contact with humans. And here you see in a higher resolution, the universal robots 5 and 3, and our robot is here. It is way beyond what this technical specification had expected at this time it has been developed. So we were way beyond. We also received a number of awards. First of all, the European Robotics Technology Award in 2009. We also got award at the handling fair, MOTEC. We also got further awards here. So our market hypothesis was the following. Of course, this is a slide from 2015. We foresee this large growth in the collaborative robotics market. It's still largely growing. And we made a comparison of the landscape. We have applications which are not so frequent, which are not efficient for high frequency, high cycle, and we need low cycle times and setup times, and we have a high degree of collaboration of humans or safety requirements. And these are the examples we looked at. One is automation of handling, picking, or something in laboratories. We have a quality control examples or connecting of machines. So the idea is the robot is used or collecting here some sorting products in a tray, for example. These are pictures. Besides this one, these are pictures from more or less pilot customers. The idea is we bring the robot to the place, and the robot is taught in the movements just by moving it and by the software, and the robot quickly learns the motion, and then it does it the whole day, sorts these incoming parts from the production machine into a tray, so that from time to time the human can just move the tray away. But the human does not have this monotonous work. So that was the idea. This is an example of pilot project examples we did. So this was the end-of-line quality inspection of high-end washing machines. These are checks done by an international producer of high-end household appliances and white goods. We had an international leading automotive supplier. We had circuit board handling. And we have automation in laboratory automation. These were some of the pilots we conducted. And yeah, I will come soon to the outcome. So the team in this case is a bit unusual. We started with a research project at TU Darmstadt already in 2004. We had several research projects for this. And in 2009, a young industrial engineering graduate come to us and said, I would like to do a startup. And we said, hey, we have a company idea. And so we started the company with an exist stipend, and successively, with the increased funding, we added positions for chief technology officers, developer sales. We did a number of co-development in joint funded project with TU Darmstadt. And as we went along, advisors entered, also business angel entered into the thing. Now it turned out that we have to do some adjustments to the team and the development. So in 2014, we had a new CEO entered, which was an experienced manager from industry. And the previous CEO becomes the sales lead. 2015, a new CTO has to be hired as the previous CTO left for private reasons, the area. And yeah, so this was the development. Then funding. So we started the main research with 2 federal funded research projects. This was at that time in a bionics program of the federal government. In 2009, we got the Exist Founder Stipend for just the CEO, just one person. Of course, we established the company in 2010. And in 2012, we had the first funding round, the seed funding with a large public-private investor and 1 business angel. We had then a second funding round which added the investment branch of a smart and medium company. We had added a public investor and a second business angel. And we also did a number of public-funded research projects between company and university. And we also had some kind of in-kind funding because we also had related projects for students, projects, bachelor's, master thesis, and so on in this direction. So the outcome was the following. The highs of this development were over the course. So we started with a key supplier for the hardware development. And during this process of years, it turned out that we needed to bring in the complete hardware development in-house. And this helped us to reduce the cost of production, improve the functions, and improve the reliability, because we just reduced the parts of the robot. Just a simple thing to increase cost and reliability. We had many customers and also some of the investors, the actual and the potential investors, they were impressed by the capable and easy to use software of this robot. And the key customers, we had also at the end, we had key customers which were integrators for the laboratory automation industries, which were really seeing this as a unique chance. And this was really a focused market where we could have made a key lead, a key impact and key market share. And they were even willing to pay us upfront for a number of robots to give us advance money. On the other hand, the final bridge financing failed, which we needed to roll out this final product for the last 6 months to get these payments from the customers, because the main investor, the lead investor, did not support it. Although the other investors were willing to give money, the lead investor didn't give it. And then the other investor said, oh, you are the lead investor, you have special agreements anyway in the contract. We do not solve the problem for you. If you don't participate, we don't participate. So the company went into insolvency. Yeah, so the main reason for failure was that, looking back, the development, the path to market with the core hardware supplier was not focused and not fast enough, which means we did not reach the product reliability needed when we needed it. Because we had prototypes at the end, which were considered to be products, but the prototypes had frequent failures. And as we were selling it, not the hardware supplier, they came back to us and we had to fix them. And this fixing required significantly resources and slowed down the overall development. So we ran out of money too fast. That was the main reason. But although it seems technical, it's also a management issue, because in the management, it should have been understood much earlier and to be handled much earlier. There could have been earlier decisions. And this was, at the end, the reason for failure. Also, we had the backup ideas for restarting from the insolvency did not work out because of some other unexpected problems occurring. So that it failed. As a researcher, I still would like to give you some examples of the. So this a test which we did for parameter calibration actually. And you see how fast this robot can move. It is so fast compared to other robots. And now you see our coworker, see how easy it is to fix it. He just says, maybe I add another clamp. But he is so confident that nothing will happen. I still imagine how many further research could be done with this type of. This robot has a significantly reasonable repeatability, and we show this with a needle. And here you see that it's, of course, this needs a very careful development of the hardware and of the software. Hardware, these tendon-driven things are not easy to develop. You need a lot of technology to make this robust enough. And of course, the software, treating all this mechanical elasticity in the actuation. So this is the first case. The second case is Free Motion Systems. This is the company which existed also a few years, and it addresses the safe autonomous stair-climbing wheelchair. Now here we started with a market hypothesis. We looked at the daily obstacles for wheelchair users. So these are, for example, just these steps in everyday life. If you just cross a street, or there are stairs, so many stairs in our life, very hard to reach with a wheelchair. Or going into public transportation, it's so challenging, even to go into a train. And it's very challenging to do this. And if you would have a wheelchair which is able to autonomously climb into this opening, it would so much simplify the life of the people. Or if you have a wheelchair, would help us to reach up to reach higher shelves in a supermarket. Or if you're walking or locomoting, to have the same height of eye level like people with legs. This would be really great. This was our first market we looked at. But then, we investigated several markets. Another is transport of people. Many people need to be transported from their houses to the hospital for some reason. And this always needs two people. And this makes for these people very challenging for the health, for the back and so on. And the idea is, hey, if you have such a robot, then you could teleoperate the robot and you have the patient sitting in, and you just need one person. And this helps you prevents the back pain, and also prevents if you have less people available due to the demographic change. Another secondary market we looked at is the transport of heavy goods. So how do the washing machine being transported the stairs up to the doorstep of the customer? Yeah, so he needs two people doing this heavy lifting. So we looked at all these cases also. Now, our technological innovation was the following. We started with looking at a walking robot, because walking with legs, you can overcome almost any kind of obstacles. But because you're going to carry a heavy load of up to 150 kilograms, then you need to be very safe. And our assumption was at any time you have at least 4 legs in contact with the ground and 4 other legs which may move, which may swing and change position. And this makes it extremely safe because we have static stability in a leg locomotion. And then you could do this. So this is our first demonstrator we worked for. You see these 8 legs. It's more like a kind of a spider or something. Here you see this part of this demonstrator manufactured already in-house. We are in computer science. This is a typical computer science laboratory, by the way. And we discontinued this one. I will explain in a short, but I will show you some result here. So this is the real perception module developed on an outside stairs here of this building. And this is combined with the path planning and trajectory planning of the simulated robot. So just as an example of the technology, this is the first demonstrator. Then we move to the first demonstrator with this 8 legs is kind of the research perspective. 8 legs with all these joints. It's nice, but it's also it gets costly because of the many joints and actuators. So we come up with an improved design, less actuators. And this was so they had 8 linear legs, also 4 pairs, 8 linear legs, which we use, which can also should we move backward to extend between them. And this shows you the demonstrator. We had a full demonstrator here. And what is shown is the contact. So in each leg, we have contact force sensing so that we can feel how firmly the foot is placed on the ground, because this is an element for safety. It's just one of the features. And here you see, what you don't see is the RGBD camera in front of the robot, which analyzes the stairs. And here is the robot moving along these test stairs to autonomously climbing up this one. Of course, always we use safety belays for this testing. So we had a demonstrator developed, and of course, the cost would be quite high, which we expected. So it's more it's not in the 10,000, but more, I would say, the 60,000s upwards. And this is an extremely costly product. And to all this project, we were in contact both with advising users group of wheelchair users and of other experts from the healthcare market domain. And they told us it's too complex also to start the market with a product, because the complex your product is, the more efforts you have to make it ready to the market. And here comes in the concept of the minimum viable product. And before just give you an impression of the system architecture we had developed here. We have a user interface, we have motion planning, we have 3D world model, we have state estimation, we have motion coordination, force control, driving and steering control, and lots of elements. So this is kind of the complex software architecture developed, and lots of developments beyond all this. So the idea of the minimum viable product is, what is the smallest, the least complex product which can have a significant market for you. And for this, we thought we scaled it down so to have less actuators and still capabilities. And this is was the first version of a minimum viable product. This is a highly innovative wheelchair, only limitedly able to not doing stairs, but doing some steps, but having a new type of mobility for wheelchairs. And this is the demonstrator. So you see that this electric wheelchair has an amazing ability of locomotion. And this gives wheelchair users the freedom whenever they need, for example, to go to a lift and to enter the buttons. It's very hard to do. They need to navigate a lot. And with this wheelchair, you can just easily move in any kind of direction. This is the user interface developed. Of course, what's nice is we have a rear view with a back camera. So you see this also some details. This is this fisheye camera. Here you see some details about the actuation and the drivetrain. So these are these unique features in this type of wheelchair. Such a type of wheelchair is not available on the market. Now you look at this one. Imagine a regular wheelchair trying to do this. It takes a lot of moving back and forth. Now, what's interesting with this one, this is you can go smoothly indoor and outdoor. We have two types of of modes. One is a relatively slow motion for fine mobility, and you can scale up to very fast motions. And you can directly go outdoors with this robot immediately. And this is a test drive. So it goes quite quickly. It can handle suspension and hose. So it removes this. There are also these electric mobility chairs. And this is the integrated the wheelchair with the electric mobility chair for outdoors. We received a number of awards for this concept. We received a main award in the Federal Ministry of Economy's Digital Innovation Founders application. We got an award in the Science for Life Venture Cup and so on, and a few other awards. The team, we started in 2016 research towards this project at TU Darmstadt. In 2018, we started with the Exist stipend. We had 3 key positions for the CEO, who is a business graduate, former already CEO, and he brought the original idea. We had a software and systems architecture position and a hardware mechatronics position. That's how we started. And at this time, we worked on, I would say, single legs and concept. But both of these students, although they were fresh graduates, they had been working as students on the project before for quite some time. So we're not new. Then in 2020, due to another startup funding project, we could add 2 more now full-time positions to 5 full-time positions. We had hired another lead software engineer, a very experienced postdoc, and a control engineer. Also very, very talented people, very capable people. And then we had lots of students in this project, really lots of student works, which were extremely helpful. I think it will have been more than 30, not just 20 student workers. Now, how did we fund this? So we started with the Exist stipends. We have the project by the state of Hesse. And we had a bit award money we received for the award, and we had used significant university funds to support this during the development. So what was the outcome? Oh, the highs first. So we showed a successful proof of feasibility of a safe autonomous stair climbing and load carrying robot. We developed a highly capable, minimum viable demonstrator of an electric wheelchair, which is not yet available on the market. We received very positive feedback from the continuously involved wheelchair users group. The lows were it's healthcare market. And healthcare market is generally very tough, and it's especially tough for high-priced products. So in addition, in this market, you need an additional certification as a medical device, and this takes more time and costs than in other markets. And the end users are not the ones which are paying or are able to pay if you go into scale. Who pays are the insurance companies and cost bearers, and they pay as little as possible. They told us, we had letters that they told us, in principle, yeah, we can pay for this type of wheelchair. But I know from practice, you only get such a wheelchair paid by the insurance if you have very good individual reasons. And this means this market is not pulling for the product, but you need to push each of these high-priced electric wheelchairs into the market. And this is not a good situation for a startup. So another point is that the distribution in this market goes through medical stores, in Germany, Sanitätshäuser. And we learned that they take an I would say, extraordinary large share of the price, much higher than we ever expected when we learned this. So the margins getting lower and lower. So this is not good for tech suppliers. Even in the wheelchair market, we talked to some of the largest companies in Germany, and they told us they tried several years ago to develop such a kind of wheelchair, which we did it. But they told us, we wanted to give them the IP to the lowest possible price. At the end, we just wanted to go it somewhere in the market, but they told us for them the market is not attractive enough. Even if they get the IP, it's still too much effort to push every single of these new wheelchairs in this high price market. So there was no market. Then it was also, we of course start to talk to the secondary markets, just like the last mile delivery of heavy goods to customers' doorsteps. And we had someone, we did this 2-person deliveries, and the company's innovation manager says, oh, great, that's what we need in the future. Then we talked to the people doing the organizing. They said, no, we don't need it. We have enough cheap muscles. So the timing is not fitting. They will need it in, I don't know, in 5 years or in 10 years. But how can you wait for this? Everything's changing. So there was no market. So we had to stop it. We had to. Yeah. And so this was the example of a robot every end user wanted, but no one was willing to pay for it at the end. So this can happen. Now let's come to the third example. This is energy robotics, and this is from 2019 until today. The technological innovation started with our participation in the Argos Challenge. This was organized by the French energy company Total, and they wanted to develop the first autonomous robot for remote inspection of oil and gas sites. And they put a number of challenging conditions out there, and they selected 5 international teams to go for it. And they had 3 years, and each year there was a 1-week competition on a training site. And the robots have 5 days in a week. Each robot has to do a mission of about 1.5 hours. The 5 different missions in 1 week at the regular weather conditions, which are there. And this has been partly in March, so it's not so comfortable for humans and also not for robots if they are not waterproof or something like this, robust enough. And so this is there is much more potential for the inspection of capital-intensive market, but this is a pretty tough environment because we have uneven ground, outside environments. We have outdoor influences, largely varying environmental conditions on lightning, on rain, or something like this. We have often GPS-denied areas, where you don't have GPS, and you have often limited wireless connectivity. You don't have the 4 or 5G everywhere. It changes, it switches. So you need to compete with this. And it have often specific requirements like for explosive atmospheres. So nevertheless, we won the Argos Challenge in 2017. And this was you must imagine, there were 3 competitions. There were 5 teams. And after the second competition, the French team was leading in points. And it was organized by a French company, and the jury was mainly French. And if you know something, then to make a German Austrian team win under these conditions requires that you're really far ahead of all others. And this we achieved in the final competition. We scored so many points that we didn't need any points from the previous competitions. And in all 6 criteria, in 5, we were far ahead of the criteria, and only 1 criteria of these 6, another team was equal to us. So this was clear. We have a leading edge, and also there is a market. So we developed this technological innovation further. So we have at Energy Robotics, we have different kinds of software. First, one stack is the robot brain, which runs on the robot. What is important that we have a large hardware agnostic layer, which means we can incorporate robots which just have a control for the wheels, for the locomotion, or robots which have much higher levels of capabilities. So we in this stack of functionalities, we can adapt to different types of robots from different vendors. Then we have a cloud brain which manages the fleet, and develops a number of insights based off the data. And so this means the customers, we can provide different robots, different sensor payloads under one user interface and one data interface. And this makes it quite attractive. This is an example where you see some of the interface in action. And yeah, I would also like to give you an introduction by the company, by the co-founders, by the CEO. And he introduces the different parts of the technology also in this one. Hold.
Are you ready to shape the future with robots and AI? Do you want to work on real-world challenges to relieve humans from dull, dirty and dangerous tasks? We all said yes, and this is the impact we have made. To date, we have freed workers from over 19,000 hours of repetitive surveillance and inspection rounds, enabling them to use that time for safer and more fulfilling tasks. We have conducted over 600,000 autonomous inspections across 5 continents. Each month, 50,000 inspection points are monitored and every piece of data is processed by AI to deliver unprecedented accuracy and insights. Global industrial leaders in oil, gas, power, chemical and security trust us, including 6 of the world's top 10 oil and gas companies. This real-world impact is driven by our team members who bring decades of experience in cutting-edge robotics, AI and autonomy. Since childhood, when we have been fascinated by how robots move, learn and solve complex problems, we didn't just play with them, we programmed them, mastered them and ultimately became multiple-time world champions. These victories sparked a larger vision: to change industries by freeing humans from dull, dirty and dangerous tasks using autonomous mobile robots. That's how Energy Robotics was born. Our software platform is at the heart of this vision. Think of Energy Robotics as a universal operating system for robots. We have developed a robot brain which is compatible with any mobile robots, a cloud-based fleet management software and an AI-powered data analytics tool for fully automating industrial surveillance and monitoring. By partnering with the leading hardware providers, we integrated the most advanced robots and drones into our software and AI ecosystem, ensuring that every customer gets the perfect robotic solution for their specific needs. Our robots conduct multiple inspection rounds every day, gathering high-quality data with precision. And through state-of-the-art AI, the data collected is transformed into actionable insights, helping companies making smarter, faster decisions. Be part of this revolution and make a telling impact in solving real-world problems. Join us.
Energy Robotics is hiring experts on all levels. So we received a number of awards. In 2013, we received the IEEE Robotics and Automation Society Award for product innovation. At the same time, in the same year, we received the European Innovation Council's Accelerator Award, which provided to highly selected number of companies only an additional 2.5 million grant for development, for R&D, which is, of course, quite helpful to have this money available. The market hypothesis, of course, we look at capital-intensive infrastructure sites, which need to be inspected and also maintained. So inspection is critical. And the challenge is there is a market need for this. And this market need comes from, one is many of these sites are decades old, and they need to be digitalized. And just static sensor networks don't meet the needs which mobile robots with high quality sensors can provide as needed. So you need digitalization of these sites. So robots are a key element in the digital transformation. In addition, the costs for health, safety and environment are exploding, which means safety of the workers on site, but also you need to better monitor the environmental impact of such plants to detect leaks much earlier than before. and risks. And finally, a real driver is the increasing shortage of human workers due to the demographic change. And it's getting more challenging and challenging to get just enough workers to fill it. And this will be increasing in the future even further. And therefore, there is a large market need for solutions. And this is what we are looking here at to meet this. So some of the team, the development of the team, since 2002, we are working in autonomous soccer teams, first four-leg, then humanoid teams. And what I like to mention is all 5 founders of Energy Robotics started with autonomous robot soccer. That's how they started their robotics career. That's how they also formed a team and so on. Then in 2011, we started the rescue robot team Hector. And we were also participating in the DARPA Robotics Challenge. And this we were the only team providing software for two different humanoid robots. And this was already a challenge to the hardware agnostics we had. So one was an hydraulically powered Atlas robot, and the other was an electrically powered conventional robot. Then there was the Argus Challenge team, of course, which was successful. And then in 2018, we applied for the Exist Forschungstransfer. This provides full paid positions for 18 months. So this is more I would say, the deluxe version of the Exist program, because the stipend usually just gives stipends for 12 months. And this is more challenging to get, but is also more attractive. So this financed the CTO, postdoc, the chief product officer, and chief operations officer. All were postdocs of TU Darmstadt. And we had filled a developed position. Then in 2019, we established the company formally. And there the CEO joined, leaving his previous job then from some time. And he is a graduate of 2004. So and he has an MBA, and he has been a former startup founder. Until today, from 2021, we hired the first people. Until then, because then the first funding came. And now it has been expanded just in January to over 100 employees. And this funding, this was propelled by significantly increasing revenues and also increasing investment capital. Of course, this was 2018 when Chancellor Merkel was visiting TU Darmstadt and was signing the robot of our fresh startup. And this is a group picture. And if you look at the people in this group picture, I counted it. This was our rescue robot team Hector. Now, 10 people from this picture are with Energy Robotics today. And these are not the politicians, I would say, of course. Now, we have more than 100 employees. And what about the funding? So we started with this Exist Forschungstransfer. We founded the company in 2019. And in January 2021, we had the first seed financing. And this was by Early Bird Venture Capital and by renowned business angels. Early Bird is very famous because they are the one seed or early startup company finance which have the most unicorns created in Europe. Unicorns are companies which reach a valuation of 1 billion euros. Then in 22, there was a seed extension round of several millions, and there we had Future Regio Growth and Hessen Capital joining. These are local investors. 2023, we had the European Council Accelerator Award. So this Accelerator Award not only comes with the R&D funding, it comes with the option to add the European Union as a co-investor from the European Investment Bank. And this happened in just last year. We had the CSA financing and had other well-known now international investors joining, which are mentioned here, Bluebeard, Climate, and European Investment Bank. And in parallel, there is a strong increase in revenues, especially in the recurring annual revenues to this period. So this was the outcome is the highest. I would say we have a very strong team of founders with complementary expertise, and we could overcome any hurdles until today and lows until today. The continuous strong growth means that you need to diverse your specialists and your teams for different areas, and you need to hire more specialists, and you need more experts, and this worked well. And we came from individual proof of concept with a single company to scale-up deployments for key customers. So first you do the pilot, and then if this large company says, okay, it's good, it's ripe enough, they put it in their general catalog of approved customers worldwide. And then this is the way where you can scale. If they just have one robot, because inspection, many of the sites have capacity for dozens of robots, or some of even hundreds of robots, of inspection robots. And this is the way to scale. Still, Energy Robotics is the leading first mover in this market because we have the most customer deployments yet, also in this heterogeneity, but it is still a very small fraction of the market, and it is an increasingly large international market. The lows, I'm not telling you the lows here, but there were quite a number of lows. And frustrations all over this time. You don't see it from outside, but all have been overcome so far. Okay, now from these three examples, I would like to give you some cross-case insight, what I think matters if you do a robotic startup. The first important thing is the product market fit. This is a slide from the High-Tech Gründerfonds. This is the largest German public-private investment in early companies. So this is the value proposition, and you need to have it to solve as a solution, as a pain reliever to customer pains. And your value proposition must be better than the competitor's proposition. This is the theory. The High-Tech Gründerfonds made an analysis why 39 of their startups failed in this tech domain. And this was the internal analysis. They said no market need, product without a business model, not the right team, pricing, ignore customers, etc. You see, there is a certain accumulation of reasons. And they made an additional question. They said in a follow-up interview, what you think was the most relevant reason? And 3/4 of companies said, or for 3/4 of companies, they said the product market fit was not there. The team was only a part, and the technology development was almost never the problem. So it's the product market fit. But I tell you, the product market fit is also something the team is in charge of course. So it is related to the team. So it's an outcome of the team. What is the product market fit? First, it's important to understand that research success is not product success. It's very different because the customers don't care about technology. They just care about return on invest and improvement that they cannot get everywhere, which helps them solve their problems at a cost which works for them. This means a startup needs to change. Startup from academia need to change the perspective. Don't think from technology anymore. Start to think from the customer needs. Try to understand the real customer needs and its constraints. And I would say the bait must appeal to the fish, not to the angler. Yeah, so this is not trivial. So customer interest is difficult to interpret, especially for first-time founders and especially for founders from academia. So the recommendation is first, focus on understanding the customer's problems and not too much on the technological product development. It is better to improve the customer understanding first before you develop the perfect product, because the product must only meet the customer needs and just meet the customer needs. So it is a necessary and sufficient. And there comes another thing, which is technology hype can obscure the view on the use case. And I see this in the number of startup activities currently. Because the technology hype has a high risk of ignoring the actual customer's problems. If you focus too early on the use case, when the customer may primarily just want to try out what this new technology potential of new technology can be, but they're not solving a specific problem in the real business, in the actual business of the customer, then you have a nice pilot, a nice looking so pilot, a nice video, but you don't have anything which can go into the real business of the customer. And this is a real danger currently. So my recommendation for startups is look out for pilot customers which meet the following requirements, which have really needs, which cause them headaches and pain, which are increasing. And they cannot be solved on the market. It's like toothache. If you have increasing toothache, you're more urgently looking for solutions. Yeah. And in this case, they will be ready to pay for the pilot, because doing the pilot means the customer should pay for it because you don't have the resources as a startup. So the customer should be so much interested to pay for the pilot, and you promise the customer, hey, because we select you as this first pilot, your needs will be best met by our technology when it comes to the product. This is your unique chance to shape this technology. And this is a reasonable price we ask for this pilot. Yeah. Also, another requirement is that this pilot customer must be representative for many other customers in the market, so they have a chance to scale if they have similar needs. Then, of course, intellectual property is when you start a startup is important. It's important that your core technology has some secret sauce, or at least a leading edge over competitors, which is not easy to copy. So you must always think, if you find a new market and not many people are there, and if this market becomes interesting for many others, then there may be big sharks from the business coming out and throwing lots of money on the problem and will pass you by with much, much more money. Okay, this is a question. Do this later. Then there comes the question of patents. Early in the first startup in bionic robotics, we had patents for the hardware and technology, which makes sense if you have a hardware development. However, imagine a startup. The startup needs to have the patent so they can have the full operational freedom. But if you have the patent and just there comes a big player and just violates the patent, then you have to go into a lawsuit. First of all, you have to detect that there is someone violating your patent. And this requires significant resources to watch all over the world. Now someone is, or at least where the patent is registered. Now imagine there's a big player, a multi-billion company, and just violates it. Now you are a small startup. Will you have hundreds of thousands for paying lawyers for a multi-year-long lawsuit? So they can risk it because they just outpass you. So patents, I'm not a fan of patents anymore. Also, after 1 year, your patent becomes open. Even if it's not approved, it takes many years to approve it. It can take 5, 6, 7, 8 years. And after first, it's already open to everyone in the world. And you see in the patent offices or online people just copying it, what is there. So I don't believe in patents, I'm sorry. I believe more in software and business secrets, because software is also much harder to copy than hardware. If you have comparable hardware, then the software makes the key differentiator in the performance. So that's why software, and also, of course, software is easier to scale. As a startup from university, you have to transfer the intellectual property in the company. In former times, we did licensing from the university. And the officer at the university don't know how to do this license. The company do not know how to do this license really, and it takes lots of time. There's a much easier solution developed also by TU Darmstadt so this is the intellectual property for virtual shares. And this means the university gives all necessary IP to the startup, and it gets virtual shares. Virtual shares means you have, for example, 100% of shares, and the university says, I get virtual shares of 2%. This means they don't have shares in the actual shares. They only, if the company is sold, then from this price of the shares, they get, for example, this 2% of the price. And this is great because it has no hassle with any kind of negotiations. It gives full freedom to the company founders, and it makes much easier for everyone. And the university benefits from the successful companies. So this is the IP for virtual shares. This is the preferred model. Then finally, to close, there's more needed than high technology readiness levels. So many people know these 9 technology readiness levels, also used by European Union and so weiter, originated from NASA for the maturity of a product from idea to a commercial product. In the robotics world, now we have 4 new levels. The first one of technology readiness, I would say, is the social media video going viral. That's the first level. The second level of advances is a live demo at a fair, doing a live demo. This is much more challenging than doing a video. The third level is a successful real proof of concept pilot at the real customer. Please, not for another social media, but a real proof which really can go into production. And the fourth level, the final is, of course, the product is in daily operation at customers. So these are I would say, the 4 new readiness levels for startups. And you should not forget, coming from research, 8% reliability is amazing. It's already rare for research. But 95% is hard to achieve, and it's way too low for a product, because then you have too much problems with the customer. So you need much higher, and this costs a lot. There's the gorge of death of robotic startups, which needs to bridge from a successful research demonstrator to a robotic system in daily practice. And to overcome this scourge of death, you need to look at 4 key pillars. The first is, of course, this technology readiness level. In the conventional speaking, go from the demonstrator, which has 4 or 5, to 9, the product. And there's the Pareto principle, which tells you 8% of the functionality you get for 20% of the cost. And the other 20% costs 80%. And here, out of the R&D funding of the Federal Research Ministry, they stop at 4 and 5. So you need more funding. Then you need a business readiness level, because you need to have production. You need to have service, maintenance, you need to have sales, and so on. You all need this. This is the business readiness level of your company. And also you need a customer readiness level, because you need to look carefully. The customers you're addressing must really be able to incorporate robots into their daily processes. And this is part of a digital transformation. And for new technologies, it takes time, especially for larger companies, to adapt this. And you must be careful that this takes time, and they need to transform properly. Otherwise, you cannot scale from your proof of concepts. So these are my 3 readiness levels for startups. Now, the business model. There is CAPEX, capital expenditure, versus OPEX, operating expenditure. Customers don't want to buy robots. They also don't want to buy cars for their employees. They don't want to buy robots. They want to purchase services on a certain annual basis. Also, recurring revenues on a monthly and annual basis are much better for a company. Better for the customer, but the customer has different budgets for OPEX and CAPEX. So it's better for the customer. And for the startup, it's better they don't have isolated spikes. They have a big income, but they also have a big cost to prepare for this. And they have a long time, nothing. So the annual recurring revenues are much better. And this is robotics as a service. You finance this as you are the hardware producer. You can work with leasing companies. There are companies out there specialized on this. If you have hardware suppliers, try to work out proper models with them, because then if you sell for them, you can make shares with them. Also, as a comment, the software as value creation scales much better than hardware. So always try to do a lot of on top software functions. And you see it's also something recently car manufacturers, just Tesla switches more to this software on a monthly basis used for some functionalities. And it's the same in robotics here. This is better. Then you have this technology. Who is your customer? Whom are you selling to? Typically, you think of the end user customer, but this is a specific market branch. And in this market branch, you need lots of expertise. And it is better, instead of doing direct sales, working with service providers and integrators of the end customers, because they already working with them. And then you make them not your competitors, but your friends. They have all the contacts to companies. They have all the knowledge how this needs to be in this market area. And it's much better to work with them. It's easier to scale, easier to go to market. Then you need to look at the right balance of your team. Typically, you have the people in front are the CEO carrying the vision, but also needs to be able to manage a growing team and needs to be able to negotiate well with key customers and VCs, venture capitalists. So you need key experts and team leads for technology as you move, for production, for product manager, go-to-market team. You need sales, you need marketing, you need operations, service, maintenance, and so on. And you need to look at the diversity of the team. And this is also in respect of experience. If you look for investors, some look of, is there gray hair in the team, which means does people have actual experience and not just too fresh from many things. Then you need your investors. Why should you have investors? You need to grow fast enough to secure a significant market share. Because the larger the market opportunities, the larger competitors which can outpace you. If you go to novel markets, you need to be fast, you need to be first. If you are first, you can achieve a lock-in effect with early adopters. If they use your robot technology and are satisfied with your price and services, it will be much harder for any competitor to be better than you. They only need to be dissatisfied with your products and services before they consider switching to another. So this is therefore we need investors. So which investors? Investors are different. In general, it's good, if possible, to look for smart money, which brings you additional value, like helpful advice, connections. It's good to look beyond the current funding stage. There are venture capitalists, there are strategic investors, there are business angels with different interests. Important it is that public investors, usually from the state or from the local state or the federal state, they can match up private investors' funds of up to the same amount in a funding round. And this can be very helpful. Also, if you look for investors, if investors have own experiences in company building, they may better understand your needs and pain. And also the public funding can be very helpful, but only if it is really in line with your plans. If you do an R&D funded project, which you think gives money, but doesn't help your development path to the product, it is a distraction. And it is not helpful. So a startup is a marathon consisting of sprints. Sprint to the next product version, sprint to deliver to a customer, but also sprints to the next funding round. Usually, funding rounds can be between 1 and 3 years, depending on development. But in practice, a funding round can take many months, at least I would say 6, 9, or 12 months, until you have found the right investor combination. And it's pretty tough because you're running out of time if your money is going down and your burn rate is there. And it's a challenge. So my final remark is, but you need to prepare for this. So why should we do a startup? I like to quote Steve Jobs on this one. He says, only start a company which is very different than research if you feel pull to it. Because you need to have this pull because it gets hard at many times. A startup has usually no exact map and no guarantees. And you build something that does not exist. You have lack of information and need to have plans which break quickly and need to be adapted quickly. But one of the upside is you have the chance to put something real into the world that would not exist without you. And you know, if the urge is strong, you already know. So it needs something you need to be willing to So it need to give you satisfaction. And a final word I would like to give.
Well, I've forgotten how much work it actually is to start a company. It's a lot of work. And you've got to do everything. You've got to come up with a name. You've got to come up with a logo. I mean, in addition to designing the product, you've got to figure out what to design. You've got to figure out how you're going to get it to the marketplace. You've got to do a part number system. You've got to go get bank accounts. You've got to set up charts, general ledgers, get a management information system, get a little kitchen set up, get a coffee maker, all this stuff.
I'm convinced that about half of what separates the successful entrepreneurs from the non-successful ones is pure perseverance. It is so hard. You pour so much of your life into this thing. There are such rough moments in time that most people give up. You've got to have an idea or a problem or a wrong that you want to right that you're passionate about. Otherwise, you're not going to have the perseverance to stick it through.
Because it's so hard that if you don't, any rational person would give up. It's really hard, and you have to do it over a sustained period of time. So if you don't love it, if you're not having fun doing it, you don't really love it, you're going to give up.
Okay, that's the final advice. Thank you very much for your attention.